also going to grab this ground signal here. We want to make sure that we ground it. We don't want to ground it to our 12-volt circuit. I see too many problems from that. So, but we do want this. Speaking of ground, we got our push signal, but then we also have a ground connection. So we're just gonna make a rail here. There we go. Make junction dots. So 5 volts, that's going to power on this. We're going to come around here. And that's going to go straight to 5 volts. Let's hit the ground signal. And this will now power on our NFC chip. Okay, those are in ground, and then I want the Hall effect sensor, and I want that ground signal. So this is going to be our high, and then our low. We're going to come around here. We're going to jump over that ground. Then we're going to jump over the push signal. We're going to come around here, come up, and then let's junction into there. Okay. So pin number 2 is IRQ, and then 3 is RSO, so 2. Let's clean this part up. Start here from 3. Three is I'm sorry, it's labeled IRQ, my bad. Thank you for correcting me. So now we have a problem here. Okay, so 11, Hall effect sensor, 2 is IRQ. Is going to be our actual signal, so we're actually going to come down here, jump over that. Whoa. Come on down. We're just going to go around everything just so we can get over here. Last one. Boom. All right, whatever. We're gonna go sideways, even though I like only going north, south. This is just a rough draft, you know. So I can think, you know, so I can look at it and kind of it can make sense. So it looks like our ESP32 is now connected to our PN532 board. It looks like we got everything, but we got this guy up here. And this is sort of the trick. So of course we got ground and 12 volts. So this is actually going to go into our 12V line. Just do G for ground. So 12 volts and ground. Now that needs to come down to our this board right here. So then we're just going to jump it. Going to come across here, jump. Boom. And then 12 volts. Oh, I think I should rearrange a lot of this. I think I need to put this guy like over there. All right, yeah, that's what I'm gonna do. Okay, let's just reconnect these lines. Fix my 5-volt rails. All right, we got this. Then we got this. And let's just get rid of you here. We're gonna move this down so our diagram isn't completely screwed up. And then I'll just put it right here. Oops. It's AD, right? Alpha, delta? Yeah. AD 2000. This is going to have a bunch of pins at the bottom here, so it kind of works out. First, it actually is 12V, then ground. So for 12V, we are going to go here. And we're going to plug right into our 12-volt line. And then our ground signal will do the same. Plug into that junction. You know, I kind of feel like I don't need to box the ESP in anymore. So we're just gonna, there. Man, this is a mess. everything connected. Okay. Okay. All right. Ground. So we got our push signals going to ground and push. It's normally closed. Our normally closed plus will go to there to ground. Push control. Okay. Let's see what others. Okay, we got a lot of other boards in here. Something I need to do is be able to read from, I need to be able to read from this. So I think the goal is to see if we can make this, the ESP32, the main controller, and then this AD2000 right here. On this board too. Okay, so we got, so far this is on. We need to at least get the push pin on here for now, but I'm gonna have to actually do some reverse engineering and try to hack this little guy. I found the data sheet, it's huge. It's huge. So I'm gonna do that, dig into those documents. So we'll get the push, we'll at least get the push in, so. Okay. So now let's think of a workflow for this. So we have right now actually our ESP32 is not powered on. Let me look at the documentation to see if I can drive this with 3 volts. Yes, I think I can. Well, I have 3 volts going to the Hall effect sensor. So this is the ESP32, and I'm going to write the C6 family. And I got an N8. And we're going to write Hall effect sensor right here, so I know this is Hall right there. And then push switch. Nah. Ah, dry. Oh man, I gotta rearrange all this. This is not looking the best it could. But at least I can see. Okay, I don't like that this is red, because I'm trying to keep that in from like sources. This is 5 volts out, but usually the ESP32 has a 3 volt pin, and I'm wondering if I can supply its voltage through that, because it has a low voltage. It's a RISC-V chipset, so which is why I tend to choose RISC-V over your typical Raspberry Pi or Panda Latte or whatever. All right, so ESP32 C6 data sheet. C6 series. So if you want to look at this with me, I'll throw this on the screen. And we'll just throw this on here. We'll transition, and let's see. Oops, not there. Right here. Okay. So, yep, see, it's got the RISC-V, Wi-Fi 6, Bluetooth, Zigbee. This is what I really want. Are you going to tell me? Zigbee's a wireless communication protocol, blah, blah. Okay, whatever. We'll get into that later, but I'm really excited to use that. All right, so we got the C6. Where's the table of contents? Oh, is there no table of contents? Bluetooth, power management, deep sleep 7 microamps, low power, memory remains powered on at deep state. Yep. Here we go. Oh, that's where I want to go. All right, here we go. Power pins. Okay, that's this. All right. QFNO pin number. VDD SPI input. So 23. Let me see what I had put on this guy. So 23, I might need to update. 23 is VDD SPI. Why doesn't it say that there? I'm going to write that there. VDD SPI. How do I do like an exponent? I want to turn this into an exponent. Somebody! Right here? So insert. Hold on. All right, let's just we'll jump over here and we'll just say cube symbol. There we go. We're just gonna go copy right here. Close that down. Ah, what the heck? So let's go back. Copy. There we go. Okay, so now back on track. VDA 1, 2, ground. Okay, so base. All right, here we go. So input power. So yeah, I'm going to power this with the 3 volt. So the 5 volt is purely output. That is not, if SPC is used to power VDDI SPI, the voltage drop on RSP should be accounted for. See in conjunction writing to E fuses the voltage. All right, so 3.3. Now I need to look at the 5 volt pin because there is a 5 volt pin. So what we can do is we're going to find our 5 volt. There's, hold on. There's a, where's the pins? Pins, 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 pins. Where is it? All right, pin layout. Well, I guess there wouldn't be a 5 volt pin on the actual, on here, the 5 volt pin would be on the actual board. Like it's added in by the maker of the development board. So the ESP32 is just a small chip on it, but let's see if there's, if it ever covers it. So 40. All right, fine, we're gonna clip this off, throw this back over here to the diagram. All right, we might got to jump into the our electronic bench and do some stuff to it and see what the properties are of that 5 volt pin. Because if it's like a crappy inductor boost circuit, I might think twice, and I might go ahead and do a step down, like power it from the battery. Okay. Wait, this isn't. Okay, so I need to this has messed me up before with the 5 volt pin, but I'm pretty sure all it does is there's a voltage regulator in here. So what I'm going to do is I'm going to, let's, yeah, I'll take you with. So grab the phone and I'll jump in the screen just using my phone, and that way we can go over to the lab bench and use the oscilloscope. Oscilloscopes. Okay. Oh, I always do that. Why do I always hit the aperture ring? And, okay. We'll close, we'll open the aperture up a little bit. Is it close? Close the aperture? I think you're closing the aperture by letting less light in. Yeah, so the small's getting, the hole is getting, no, the hole gets bigger when you close the aperture, and it gets smaller when you're opening the aperture. I don't know, it confuses me. Sorry. Let me just do an audio check real quick. Make sure audio is on. Of course, everything is a little blurry. So let's do this. We'll step you down. Oh, that's why. Sorry, guys. So this is what we just did right here. You can probably barely see it from your side, but that's fine. We're gonna bring you in here. So I gotta join real quick and then turn the microphone off. All right. I think we're in there. Let me just pop this in, set it up, open it. 2. Okay. All right, I'm back online. I'm still not seeing my camera though. There we go. I'm on here. Oops. Video. Hey, okay. So we're gonna set you up. So we'll do a little bit of hacking here, a little hardware hacking. Okay. I'm just gonna tighten this in. All right. Okay, let's grab the board now. Power supply and a board. We're at 7.8. Let's go down to, we'll go straight down to 3.3. 3.2 is fine. Okay. There's that. We got ground on the other side. Okay, so now we're on. You can see the little red light on it. Actually, I don't even know what kind of sketch is on it. But all we really want to do now is to test this 5-volt pin. And to do that, I'll use my oscilloscope here. And let me hook it up so I can show you what I'm doing. Okay, so I want to hook this up to a ground, but what I could do is just do that. It almost looks like we have a 25-volt signal coming out, which would be mad. So let's just ground this pin. Oh, we're on 10x, so let me go down to 1x. I have 1 volt through there. And we're making sure I don't have any shorts. No. I'm getting 120 volts. Oh, someone's calling me. Hold on. It's on my phone, so. Yo. What? You're here? All right. Walk to the side. All right, walk to the side of the building. I'm going to open the side door. Okay, so I might lose you on my audio because I'm wireless right now, but we'll see. If anything, I'm scared to push that button, but we're just gonna take you on this tour right now. So I'm just gonna let in a couple friends in here. And, all right. Close the door when you come. All right. So these are my friends. They're coming in right now, and I am going to jump right back at you guys and do that. So something is wrong with this board. We got to figure out what it is. So we'll have you looking at this right now. Oh man, so many people are calling me. Hold on. I'll call you back later. Bye. Okay, I'll talk to you later. Yep, bye. Oh, all right, you're on stream if you come over here, just letting you know. You're on stream if you come in front of the camera. So you are live right there. All right, so we're switching over here. 3 volts on, 3.3 volts. And we have to sort of reverse engineer and see what is this 5-volt pin doing. And I'm gonna guess there's an inductor actually I see 2 MOSFETs. Why is this saying 5 volts? Can I put 5 volts in there and then there's a regulator? Okay, let me see. Let's see. I don't want to do that yet, but I might. It's my only board, so I'm not going to do that yet. But as far as I see, I get nothing I get nothing but 1.20 volts. See? 120 volts. 160. Okay. Yeah.
What are you trying to do?
We'll finish that. Connect it on the other side of the whiteboard.
Oh, that was the system?
Mm-hmm. Okay. So, oh, I'm still on my phone. Let me just throw this in here like that. Okay, so for now, our 5-volt pin is going to be a question mark. Let me get off here. Let's see, this should, okay. So 5 volts is a question mark. Who knows? So we're going to keep all right, and then here we'll also add a 3V pin. We'll say 3V3. Oh, okay. Find. Can we see that? Can we see this? Can we see it? Oh. All right. So our 5-volt line up here. Oh, is this the problem with these double end markers? You take it off, you can't put it on the other side. So 5 volts. Where are we going? Oops. We don't know where. We do have a 5-volt line, and as I referred to the data sheet, there is no 5-volt line for the actual board. So I have to look up the dev kit that they released the board on, because the real ESP32 is it's just this silver square right here, and all these other things are what the dev kit uses. So there's like a UART converter and voltage converters and other things that for the pins, some special use cases, and the buttons to put it in reset and program. So yeah, looking at the data sheet, there is no 5 volts. So what I'm thinking is that you can input 5 volts if you wanted to. It'll go through a 3-volt regulator. Oh, where's the, all right, I'm just gonna visually scan the boards and then see if they have similar constructions. Okay, so for now what I'm going to do is I'm only going to set up a circuit that regulates a 3-volt signal, 3.3 volts, and then have a separate, like a Bucky converter. So we'll put right here, so we'll say 3V3 right here. And then we'll have a sort of like a shunt regulator, diode involved in this. We'll have an inductor, we'll have a capacitor, and maybe like some kind of small RF filter. I'm just going to put a question mark. We're going to do voltage regulator question mark. And I guess that's it until, so I'm going to rewrite this document down and then just come back and then show you what I did. So, oh, I didn't have to do that. I didn't have to do this. Hold on. could have just ground. Okay. Well, that's the horrible drawing, and this is the project. And I think every component is accounted for, except for the voltage regulator, which is super easy. So we'll start hooking all this up on the breadboard, and then come back to you, and then we'll jump into the software. That's it. That's it. I'll come back. Thank you.